Hello, everyone. My name is David Leclerc. I'm the host of the ChUG podcast. And this is the chatting around the dumpster fire edition of our podcast where we discuss about everything that's super relevant. I'm here with Ryan Duggan, who runs everything flow stoichiometry at AbbVie. Bert Ladd runs everything flow stoichiometry at Loyola. And our very good friend, Rebecca Bultema, is now with Nodexis. What's your title over there?
Senior technical sales specialist, something like that. Yeah.
Very, very nice.
Yeah. Titles. Who needs them?
What is new with you, good people? Anybody traveling to any fun meetings this year?
Anybody going to CITO?
Edinburgh?
No.
Nope.
Unfortunately not.
This is a trend in our podcast. Like we talk about CITO and we never go.
Yeah.
I'm going, I think AAI is running concurrently at that time, and that's in Chicago this year. So I will be at AAI, and of course, the annual course it's in Madison again this year. So I'm going to that, GLIIFCA in September, and Autumn Immunology Conference. Those are the ones I know I'm going to this year.
Right.
Mm-hmm.
At the time of recording, we're in the second day. We just finished the second day of the Flotex meeting, which we're not there, but they put everything on YouTube. So that's very nice of them. And it's actually, have you guys looked at any presentation today or not yet?
Not yet.
No. Any recommendations?
Kind of nice. The yesterday was all training, mostly going to the basics of multiparametric analysis, staining panels, stuff like that. Today was clinical. Tomorrow is more sciencey stuff. But I like these people. It's a very nice, easy way to present the meetings. Shoot it all on YouTube and don't worry about it. And it's great.
Yeah, they kind of have everything in one room, so they could set up their AV and take it away. So
instead of the issue of like the presenter looking back at the screen in front of the room, and then you lose the sound every other word, but otherwise it's really good.
Yeah, me just
read lips.
I'm just staring at the top right corner of my Zoom window the entire time we record, so I can't really comment on that.
What else is there? Did you guys look at CITO? We're not going because it's in Edinburgh, but I looked at the program and it's kind of feels like this year feels better than last year. It looks
like, I thought there was like at least the stuff that I was interested in seemed like kind of a repeat last year. Like there was this whole like flow analysis algorithm workshop last year that I went to that was basically like, oh, do you start your analysis by doing, flow clean or eco QC or whatnot, and kind of getting through that first pre-processing steps. And it seems like they're redoing the same thing, because I filled out a survey that was basically all the same questions that were asked last year. And the thing about last year is we went through so much like survey data or people adding their 2 cents that absolutely nothing got accomplished. There really were no conclusions to the workshop, which is like, I just want, even if you're not 100% sure, just put out a proposition and say, here, this is what I think you should do. Now, somebody prove me wrong. But I don't think anybody's willing to do this. All like, yeah, let's all talk about it and do what everybody wants to do. Build a consensus. Yeah. I'm more of a monarchy kind of guy, Tell me what to do and I'll do it.
Do you think that's why they're redoing it? So maybe they have some sort of conclusion or some sort of go do it?
Maybe, yeah. But I feel like a lot of workshops end up like that, where it's, we want to get everybody's input and we want to send out those surveys ahead of time, and there's really not, you lose a lot of the meat, a lot of the substance then by just trying to build it up. So
I think there's the worry that if you come out with a strong opinion, you'll have like the one guy in the back who disagrees with you, and he'll just like steal the entire time arguing with you.
Sure.
But yeah, I mean, you have to have like a thesis, right? Otherwise, why are people coming to the workshop?
And still, that is still more fun than just listening to the results of a survey that you run and like a handful of people answered. And
having hosted a very combative workshop, that was the most interesting part of the day.
Yeah. So. But see, you didn't have any survey yourself in your workshop.
Yeah.
Therefore, can we say a few words about GLIIFCA? Rebecca and I are on the board of directors, so we're going to say nice things, and we're obviously paid millions of dollars to run the whole thing, billions. But this year, Daniel Vassell is the president, and he's having fun. And he's shuffling stuff around. Like I think Laura started a couple of years ago, and she started just like spreading the meeting, like making it a bit more breathable. It used to be a slog to go to GLIIFCA. It was like, like a presentation, a bit of wine, presentation, go eat something. And Laura removed a bunch of stuff, make it breathe more, like get people to talk to each other. And this year, Danielle is bringing in, well, first off, he's cutting the Sunday morning session. So that's a giant bonus. Like we used to like try to catch people as they left the meeting on Sunday morning, try to tape them on chairs so that they listen to the whatever sessions we had. Not doing that anymore. So the session finished on Sunday with the banquet, and that's like fireworks and whatnot. And then he's also bringing 2 days of actual instrument demo. So not just the instrument in the vendor room that's kind of turned off for just an empty box, but actual instruments that are going to be plugged in. We're going to run beads probably just because of biosafety concerns, but still people will be able to like actually run them, play with the software, see what they can do. So no, we're kind of, we don't have names yet on who signed up. We're still recruiting, but
I think that's going to be a great addition because there can be up to 12 different demo site people that give demos there, and we're going to run it like a round robin. So you go to each of them, and then if you want to go more in depth, you'll go back. So I think that will add a whole nother level to GLIIFCA, which will be great for folks that want to see certain things, but maybe they don't have the money now or this or that, and they'll be able to see all of that at GLIIFCA. So I think that'll maybe make this more of a destination meeting for a lot of people. So it's kind of cool, this new advance that Daniel's put in. So yeah.
Was that on Thursday?
Yeah. So that
Thursday, Friday then?
Thursday, Friday, and then at some point there's like a shift where the vendors go to the vendor room or whatever. But yeah, so that'll start Thursday morning.
Talking about Daniel, I have to be curious, is like spatial biology, is he looking to include that more? I know that was he was talking about that at GLIIFCA last year.
Yes.
He invited a couple of companies that I'm phlostometrist. I think microscopes are yucky. And so he started inviting companies. I'm like, ooh, what is this?
Yeah. So. I am definitely interested in the like spinning confocal. I think those boxes could have, basically what he said, I don't want to restate his presentation, but I think those could definitely have like a niche and a core. Like I have people wanting to use like the image stream, for example, but they have just incredibly messy tissue or something that like they're losing so much information if they put it into a single cell suspension. They care about that really like, positional data that they lose. So I don't know. I probably don't have the money just to throw anything new into the core right now, but I am interested in that to see if that'll like kind of synergize with Flow.
Yeah.
Sign up for GLIIFCA. Come see all the boxes.
I'm there. there.
There are two I's in GLIIFCA.
That's
so
right.
Yes.
We're not just international, we're also imaging.
That's
Yes.
right.
And like with even like these new things that GLIIFCA has, I mean, really, who needs to go to CyTO? You just go to GLIIFCA.
Well, I
You
think
see
a
all the
lot
same
of the
instruments.
I think a lot of the regional meetings are so substance rich that, you go to a few of these regional meetings or, maybe get invited to talk at one and you have your normal one you go to or something. They're really dense with great people. I know we've already solidified a few speakers. I know Holden Macker's coming, Virginia Litwin's coming. I don't know who else, but like those are two very prominent flow folks in the community that have said yes. So things are moving. GLIIFCA is where it's at.
What's a the just thinking about you decided at the beginning of the year where you're gonna which meetings you're gonna attend. What are your criterias? How do you decide what do you want to see? What's interesting to you? Like I never go to any actual science meeting because it's not what I do. I'm
Yes,
kind of with
me.
Ryan on that. Like CyTO it's an expensive meetings,
Mhm.
and so and typically you kind of get this. You can pretty much find similar information if you score the internet, all the webinars, seminars available. And so I don't know. Kind of curious. What are you? How do you guys make those kind of decisions?
I mean, GLIIFCA is on my short list always, just because, I mean, as was said, I find it to be pretty useful, information dense. But also, there have been many occasions where I'm like, hey, I have this weird question or application I'm not quite sure how to handle. I talked to this person at GLIIFCA. They're 2 hours away. Let me just talk to them and see. And of course, I could do that with someone in Bangladesh or whatever. But I don't know. I do appreciate having like the local like networking and resources I can build up. I'll admit, I don't really like going to meetings. I know I have to because they're just a part of the job. But I don't know. Whenever possible, I like to keep it local and like kind of immediately useful to me.
Yeah, I think I usually try and do a technology focused one and then a science focused one.
Right.
But even like so for me specifically, I think like the science ones are, kind of just keeping abreast of what the trends are in general in immuno-oncology specifically for me. But yeah, I mean, I also a little bit disappointed because, it used to be way back when that you'd actually get some unpublished data presented at scientific talks and whatnot. And now it just seems like every figure that's thrown up, has a little EMID underneath it. Already published stuff. It's like, yeah, I could have read your paper if I wanted this
Right.
information, then like go halfway across the world and listen to you explain the figure that you published 6 months ago. But every now and then you'll get, people who actually want some feedback on current stuff that they're working on or want to show off kind of the new latest greatest stuff. But it's pretty getting rarer and rarer. I find that, everybody's so protective, don't want to get scooped, and need to get that publication that they're just afraid to show anything. But yeah, but anyways, yeah, I usually try and do something technology focused. GLIIFCA is an easy one to satisfy that criteria. And then, yeah, there's a whole slew of cancer related or IO related meetings that we kind of cycle through, me and my colleagues.
When I was in the lab and in the core, I would always go to one virology meeting and one flow meeting because I was in a virology lab and in the flow core. Now, obviously that I'm on the commercial side, it's a little different. So many times for me, it's like what's local, what's in my territory. And many times with CyTO and things, that's up in the air, who gets to go, who's, that kind of stuff. But I love meetings. I love networking, and you know how I am, but so those things are always fun. And I think looking and seeing all the posters and seeing talks when you can, it's always interesting to see what people are doing with different things. But these, I don't always have a choice on the commercial side. You kind of have to go where you go. And other times it's, yeah, I need to be here because it's important or things
Right.
like that. So,
well, are there features of specific meetings that whenever this is going to be present, oh, this is going to be fun? Like, I don't know.
well, another regional meeting that I find very beneficial is Autumn Immunology Conference
Right.
In Chicago. It's at the same place every year. People come from all over the Midwest. And I think that that's a great meeting for young investigators because everybody who has a poster gets a talk. And so many times people who go to meetings don't get to have that opportunity as a younger grad student or maybe a younger postdoc. You might not have the hottest data in the lab. Your PI might be doing the talk. So I think that's another local Chicago meeting that's definitely worth it, for people to go to because there's so much that you get out of it, presentation wise, and just being in front of a lot of really high-end immunologists that are there to learn from each other. So yeah, I really like regional meetings. I'm a part of SEPSIG as well, the Southeast Flow Cytometry Interest Group. That's a good meeting every year. Flowtex, I used to go to that. So you get a lot of great information just in the regions.
Yeah.
Mm-hmm.
They used to present on retro projectors at the
Yes.
Autumn Immunology Conference. I don't know. I was just thinking of what are kind of like meetings are competing with each other, so to speak, for our grant money. Like at the University of Chicago, we're supposed to go to 1, maybe 2 meetings a year, and so you can't really just go on a trip and do them all. So whenever you decide which one to decide, like if you're organizing a meeting, what are the things you should be thinking about to attract more people? I guess that's what Danielle did with GLIIFCA. I think the bringing instrument demo is like brilliant. So it's super interesting. The other thing I kind of want to see at longer meeting, it's something I was thinking about when I was at Saito last year, is that we have so much time and at some point you're just not going to all these talks because it's too long to like not everything is interesting. And it'd be kind of nice to be able to just grab a bunch of people and organize your own little workshop or whatever. And so if you could have these type of tools, this space available for these type of things, that'd be kind of neat.
Go rogue meeting at the meeting.
Yeah.
That's kind of cool. I like that. Yeah.
I know these places are called bars, but then, sometimes it's 10 in the morning and you just can't, stay serious at some point.
Yeah, for sure.
What else is new? I got my tune back. My tune has been gone for the lab for quite a while, and it turned out that it was a giant contamination issue where like the tubing had started breaking apart, and that's where all these microbial organisms were living, and there was just no way to clean them out. And Bert is making faces because he was the one in charge. And I'm not blaming Bert. I think
was
he was in charge. Yes.
What caused the tubing to break down? That's not a contamination issue. What was that?
I think it's either bleach with the tube and it just started breaking apart or something.
Okay. That's
So when you say you got it back, did you have to send it?
Yeah.
Oh, okay.
Because we made
They
a fuss.
couldn't.
And Thermo Fisher, by the way, they were super nice about the whole. They did a whole lot of effort to help us out with this. So I'm not mad or anything. It's just so weird a problem that. And now we started talking about, okay, well, how do we clean the instrument properly so that doesn't happen again? And is there any material that we should be avoiding? So if you see a tube that's kind of rubbery and kind of you kind of know that this one is not particularly great for this one. We'll let contamination come back.
Well, I know there was a particular press release from Thermo Fisher where there were tunes made during a certain period. I want to say there was a 2-year period where they had put biodegradable tubing inside.
Oh,
So there
thinking
was
green
there
on it.
was there was a
Wait,
press
bio.
release. There was a press release about that
Okay.
to people. So I'm just reiterating that,
Right.
and you could take that from there.
Okay.
So that was a mistake, I believe, that they made, and so they had to recall and change a lot of that out.
But I did something similar with my Auroras, where I saw the tubing that went from the sheet tank to the instrument and the waste tank. They were all I don't know the name of the material, but like kind of really rubbery, really flexible type tube. And I could see some stuff starting to grow in them. And so
What?
just like
So what are you
replace-
putting in your sheath tank?
water and with
Water?
the little antibacterial gizmo thing.
Okay.
I think it just happened. But I think, yeah, there's probably material. You're going to be more prone if your instrument has some tubing made of material that's not of as great quality. So it'd be kind of nice to start knowing about these things so you can actually replace these tubes whenever possible.
So what types of, in your cores, what kind of cleaning materials do you usually use on your instruments?
Like reagents?
Like whether it's bleach or some sort of cleaning from the manufacturer, contrad or hydrogen peroxide, like what is normal in your core to clean your instruments? Bleach or?
Bleach.
Yeah,
Is that
bleach,
water?
detergent. Well, yeah, there you go.
Yeah,
Like contract and stuff?
right.
I do 10% bleach, like a 1% contrad solution, although I'm probably going to up that, and then water to rinse. For the sorter, we use bleach, water, and Citronox, or like Helminex would probably work fine too. Some kind of acid detergent we can just leave to soak in there for overnight, ideally. But yeah, I think you've probably had this come to Jesus moment too, David. The realization that like bleach can clean, but it's really better at sterilizing. It doesn't always clean the best. And especially, I bet there's so many, not even just cores, but labs out there that have a 10% bleach solution that's been there for 6 months. And it's like, it's not bleach anymore.
Right.
But people just will use that too, or use that bottle for as long as it's not empty. I think that's a big issue, is that people just like, have like a tube of bleach that they leave next to the instrument for months and they refill it whenever it's empty. But it's like, what is precipitated out of that solution? What are you actually putting into your flow cell that you don't know about?
We were bleach and contrad people. And as of last week, we ditched the bleach and we're now using something called Cavicide, which is a cleaning agent used in medical settings, just there to decontaminate surgical tools and machines and hospitals and whatnot. And we mix it with 10% with the contrad for a concentration of 10% of contrad. And so we call this thing Cavicon, which sounds something like it's going to punch Optimus Prime in the face.
Or Comic-Con.
I mean, cavies are, I think, like capybaras and stuff. So I'm instantly thinking this is like poison for capybaras or something. Cavicide.
I'm kind of annoyed at some companies. Like I'm going to name Agilent and Thermo Fisher as the main culprit here, that they have their own product. They call them Novo Rinse, Novo Clean, and whatever like Thermo Fisher has for the Attune, but it's like bleach and some kind of detergent, like contrad like stuff. And it's, you need to use that, otherwise like, ooh, bad things gonna happen to you. And it's just like, I think it's dumb because it makes people afraid of really understanding how to clean their instruments. You need to use that thing and use it the way the company does, otherwise. And stuff happens anyway. So you need to know, what reagent will do what to your instruments. Thermo Fisher is adamant that we cannot use anything but Helminex with their flow cell, and I'm pretty sure Helminex is diluted Contrad. I can't prove it, but I don't know, but I'm pretty sure.
But here's the thing, right? If the company is saying use this or you have to use this, I mean, part of me just wants to say, okay, fine. If I still had this problem, then it's on you. It's not on me. As soon as I change something and say, oh, I'm not going to use that reagent because I always use this reagent, then I have no recourse to say, hey, this is broke or this is contaminated or whatever. You need to fix it. And I ran into this exact same problem. Maybe it was the Aurora. I don't know. I was using actually I started using like the Nova Clean or Nova Rinse or whatever it was from the Quantian as the same cleaning solution on the Aurora.
Right.
And we were like burning through regulators for the vacuum somehow. And it was like some weird interaction with whatever cleaning solution we were using, because they replaced the part 2 weeks later, same symptoms, they come in and replace the part again. We did this maybe 4 times in a row. Finally, had a powwow to go through it, and we're like, okay, let's go through every little thing that you guys are doing. So showed them the water we were using. Then we got to the cleaning solution and said, oh, we're using this Nova Clean solution because we're like, oh, it's like bleach. And so we looked up the material data sheet on Nova Clean, and there was some component of it, and they said, oh, that's it. That's the problem. Really? We stopped using it, haven't had the problem since. But so now they're basically saying, oh, well, if you would have just followed our protocol and our procedures for decontaminating instrument, we wouldn't have had this problem and had to come out here, 4 times to fix your instrument. So I mean, kind of lesson learned for me at least. I'm like, okay, if you want me to run with this specific cleaning solution, fine, I'm going to do it. But as soon as I have a problem, it's up to you guys to solve that for me because I'm following your protocol.
Right.
And this is like a new position for me because I was always like, I'm going to do it my way. I'm going to use Contrad. I'm going to use bleach. I'm not going to buy your special little rinse solutions and whatnot until it kind of bit me. And now I'm like, okay, fine, I'll do it. I submit.
Yeah, I mean, that's always the first question that they're going to ask too, right? When a field service engineer comes out, it's like, what are you using? And then that can negate a contract, or, that's what the biggest thing is, right? And also what I learned from being a product manager is really, I became a material scientist because there's so many different things that they put into each of these instruments. So depending on what type of tubing or, fasteners or this or that, certainly there might be something in one cleaning solution that can damage something in a different machine, right? So there's so many things going on in there, but that is always the first question. What did you use? Did you use our cleaning solution? Did you use our products? Yeah. I
was about to ask, because that's a problem when you have a service contract, but we don't. So but I'm giving I'm chairing a session at the next ABRF meeting on service contract. Podcasting leads to everything, my friends. But that's where my mind is going in terms of service contracts is we should be much more knowledgeable about these type of things. And it's not enough for companies to just tell us to, hey, run this and you'll be good. Like, service contracts are not worth the money in general, unless you have enough cash to throw at it. But like University of Chicago, we have too many instruments. We can't afford service contracts in any of them. Otherwise you make your data point way too expensive. So my current thinking is we need to develop a new service that companies train us on how to maintain the instrument, really clarify what the different products will do to the different parts of the machine. I think we should be just below in terms of quality of service, we should just below service engineers in general.
Some universities too, or institutions, I know Mayo, they do something where they have service engineers at Mayo that they want them to understand how to fix instrumentation.
Right.
So I know that they're trying to take that more in-house as a institutional level type of thing.
Yeah.
Mm-hmm.
I just have to wonder, I hate to be that guy, but like at what point does that become like a negative value proposition for the company? Like, are they really incentivized? And it sucks to say for us because we're core people, but are they really incentivized to give us that training? Are they better off keeping it proprietary from a profit standpoint? You mentioned the point about like having us be essentially trained like a tier below service engineers. It's like, well, that kind of invalidates the money they spend on service engineers, right?
But again, I don't spend any money on service contracts, but I would pay for that service. So I'm saying there's money on the table for these companies.
Sure.
Yeah.
You spend money on time and material though, right?
They're putting through their engineers too. Like that. Yeah.
Well, there's a certain type of person, like not every core facility is going to do what David's proposing, right? So
sure.
But the service engineers are already overwhelmed.
Yeah.
With service calls. So if whoever company can get David to do all of their work for them, I mean, why wouldn't they do this? BD used to have a program. You pay quite a bit of money for it, but they would train you to be kind of like a pseudo field service engineer. They'd give you'd purchase the tools, like a toolbox. So you get like the scope, you get all the electronic detector testers and all that kind of stuff. We used to have one at UChicago way back when, but you could then repair pretty much anything on the instrument. You still got to buy parts, so it's not like you get parts for free or anything like that. But it frees up, like, so if there's a handful of institutions that do that in the Chicagoland area, that frees up the service guy to go put out all the other hundreds of buyers that he or she has to deal with on a regular basis. And then David's not complaining to BD why they're not there in 48 hours or whatever they tell you that they should be there in.
I might still be by BD Instruments, so
Yeah,
gonna be that guy again, but you said used to. I have to wonder why they used to.
We were piloting a program like that at Thermo for a while, and kind of along the lines of what Ryan was saying. Yeah, everybody's not a candidate to do that. Not everyone wants to do it. Service contracts are fine for some people, but other people have the ability to do it and want to do it. Tinkerers by nature, right? So, but what they were doing is showing them kind of the top 3 repairs that they would feel comfortable doing. But you do save on time of the service engineer and all of that kind of thing. You save on travel, that's the biggest part, right? And then if you don't have the right thing when you get out there, then you have to come back out or ship it out or, all of those things. So at the end of the day, I think that that could be a happy medium for some folks because it can save money and I just saw a huge benefit for people that are technical and want to do that, because you don't have as much downtime. And if it's a repair that you can't do, then you have a service engineer on the phone or through, TeamView or whatever that can then kind of walk you through and say, oh, okay, now we're going to send this guy out with the part you need because we know what's going on. Right. So, So
I love the idea. I'm the tinkerer. I'm the guy who wants that. I'm not arguing for the megacorps. My point is clearly these programs are not really much of a thing anymore. And I have to wonder why that is. And do we just have like a whole perverse incentive set up with service?
Yeah.
Like you talk about having to pay for time and travel. It's like, well, what does that money go to? The company that
Tony Ledger mentioned that, and I don't think he gave an answer on why BD
Well,
stuff.
part of it, I think, is generational. I think people were more willing to work on their instruments, and then there got to a point where people are like, I just want the thing to work because I don't got time to work on my instruments, so I'm going to go ahead and pay the service contract. There's got to be. I mean, I remember when, gosh, and like Bill Gunderman was our service engineer still at that point, but he was, and this was worse with the Coulter guys. The Coulter guys were like service contract salespeople. Like they would push the sale of they had like a quota to hit. So that's like a company cultural thing. But I mean, I think if the user base, I guess demanded more flexibility in that regard. I mean, it seems like a win-win, new revenue stream, quicker. It's like turning tables at a restaurant. If you can get through more of your service calls in a shorter amount of time because, some percent of them are taking care of it themselves, you can churn through them quickly. That leads to happy customers who are going to buy your next iteration of the instrument because the service is good.
Yeah.
To be clear, I agree. I mean, I think it's like
No.
worst case scenario.
You made your bed.
If like
Bert.
crucify me. No.
I don't think that price point needs to be pushed back on a lot.
Right. I heard for good podcasting, you have to have arguments. So I'm just here to be the bad guy. I agree. I feel like, if you kind of, 75% train a core person to be your engineer and then they mess it up, well, hey, now you get to send out a time and material person and you can maybe kind of double dip on that. Clearly companies are not doing that. And I just have to wonder what are the incentives there? Clearly they're seeing something that we're not.
There's a survey that somebody at Saito did, Isaac, sorry. And it seems to me like they were asking members at large who has a service contract, and I think it's 60%, like a really high number of people with instruments have service contracts. And so I'm guessing that companies are just happy with that. They're trying to get more and more, but like that's the service contracts are priced the way they are because the market demands it. And
it's Amazon Prime for biotech companies. They get to just have like a yearly, we get this much money, and that's super, right. I'm sure attractive to them.
So you'll need another group, like a smaller group, like Scitech could do it, I guess. That kind of tries to get more share of the market by making the instrument actually super easy to use. So that makes it penetrate even more sites. And so there's a lot to be. Do you remember? Because there's a lot of confusion about maintenance of the instrument anyway to begin with. So we need to know. Remember, Bert, last year you sent an email to Purdulist and you asked. So I can't exactly remember, but I think it was your QC. Sure, go for it.
Yeah. So I'm pretty sure Scitech's official recommendation for, when you're done with an experiment, but the instrument's still being used that day, you do a flow cell clean. That's bleach and water, or 10% bleach and water. We were just getting issues with, after that bleach would run, I think my hypothesis, and doing some testing, it seemed to confirm this, the one tube of water was not enough to rinse this. So we'd get residual bleach. And, for at least the first couple of samples or controls, which is bad, of the person running that, they would get really super high CVs, gains will be different. We could validate this by running QC right after doing a flow cell clean, and we get a positive 800 gain change on the Aurora. Clearly something really going wrong there. And yeah, we just now ended up taking bleach out of that equation. We use it for shutdowns, but for the just in between cleans, we do like alcohol and water, because I really just want to clean the line a little bit. I don't need it to completely clean the flow cell out.
But where I was going to is the answer you got were all over the place.
Yes.
That was just people running all kinds of crazy ideas of we'll run contra, then bleach, then this, then that. And it was just it went from like the really what to the super interesting. Oh,
Mhm.
that's probably really the overkill type solution. Like everybody has their own ideas on how to clean their own instruments.
When you run alcohol, do you run 70% isopropyl, or what do you run?
We do 70% ethanol. I am very open to feedback on this if that's a bad idea. Definitely not something we would run without a rinse afterwards. And I am thinking about changing that protocol just to, I don't know, something that is actually sterilizing, although that's not our big concern. But I just want something easy that I can train people on. But, that's sometimes not feasible. I have to wonder if the problem is that we have inconsistency with recommendations from manufacturers. Would the pushback or the reaction to that be, well, here you go. Now you have a proprietary solution for every single instrument. There's no more guesswork about if bleach or alcohol is better because you use Aurora solution number 5 or whatever, and that's all you can run.
Right.
Yeah. And like also on the side of as instruments get easier to use, I don't think that pushes companies towards wanting to train their users. It's going to push them towards wanting to make service contracts more and more.
Yeah.
Yeah. I'm kind of shilling against my job here. Just that. Gotta be honest.
Another crisis in the world of Flowland tree. Beads are just no good. They're no good. Compensation beads, unmixing beads. Bunch of posters at the last CITO meeting, and then the paper by our very good friend. I forget his name, but he's like the guy is everything we
Budget.
everything we
at
do.
ECU.
Yeah, he's always listening. What's your take on it? It seems like it looks like a very big problem that shows up on posters and a paper here and there, and nobody's talking about it. And just today yesterday actually at the Flotex meeting, somebody was talking about how you prepare your controls, and beads were still totally fine. So is it like people don't think it's a problem, or it's not confirmed, or?
I mean, I think that the main problem is there is no perfect solution.
Right.
So I would say with a moderately sized or large parameter panel that you run on a spectral cytometer, because I think that's mainly what people are focusing on now is spectral unmixing and not just like compensation controls. You will always have to do some cleanup of that data. The unmixing is never going to be perfect if you're running like a whatever, let's say a 25 color panel on an Aurora or a Sony. I've never seen a perfect unmixing happen where I was satisfied with every two parameter plot that I looked at in an n by n array of plots. So I think you can make all these things and say maybe some bead types are worse than others, or sometimes for some colors in some conditions, cells work better. But you can't say beads don't work and you should always use cells, or cells don't work and you should always use beads. If you really want to spend a lot of time for very little impact finally on your data set, go ahead and spend days and weeks and hours going through all the different permutations of cells versus beads versus cells plus fix buffer, cells plus perm fix. I've done the exercise. Nothing gives you 100% perfect mixing. And I don't think, I think expecting it to come out with no further need to add compensation is just being naive. I think it's not going to happen. You remember David, the ChUG podcast that we did with Dave Novo.
Yep.
And he was walking through spectral unmixing. Yeah, I went through a few snippets of that over the past few days. Just because I seem to remember him basically making the conclusion that which really surprised me at the time, saying that let's use FTSE for example. The FTSE spectra, the signal that you get on like an aurora, is not necessarily the same shape for every cell that has FTSE that goes through the laser. So you put cells through, or you put beads through, and you say, this is my FTSE reference. Then you run 1,000 cells that have FTSE on them. Each one of them could be slightly different than the reference. If you drew the reference as a line, for example, FTSE might be a little bit. So it's not just that the intensity, the whole spectra, like increases or decreases a little bit. It actually can change shape slightly in different parts of the spectra, the channels that you're collecting. So we basically end up with some kind of noise that's built into the equation. And we're trying to do this unmixing based off of the ideal, whatever reference we told it. And there's going to be kind of misses in different parts of that spectral curve for every cell that goes through there, which creates spread and other things like that. But it just seems to me like we deal with that same kind of mentality with compensation, knowing that we're not compensating a discrete point in space. We're compensating a spread, from the high part of the log scale to the low part of the log scale, et cetera. So why do we expect spectral unmixing to be 100% foolproof? And, so long as we run the right set of controls, beads versus cells versus these beads versus that bead, we're going to be able to get perfect unmixing. I just don't think it's going to happen.
I have a few follow-up questions. I waited the required 5 seconds of silence. Do you think that applies to compensation as well? That there's like inherent variation in the FTSE signal? Because I mean, ultimately the spectral signature is telling us about spillover, north or south of center, right? I mean, maybe the spectral is more granular, but do you think that still applies to that? Do you think that's where spread comes from?
Well, I would say it's probably a function of the number of detectors.
Okay.
So if you have like backscan like detectors, just like huge buckets collecting, 3 or 4 parts of the spectra, I think the problem there is easy to hide. But as you increase the number of colors, so even if you had like a 30 parameter instrument where you weren't doing spectral unmixing, I don't know, maybe you'd see something similar there, because those neighboring channels that are close to FTSE might be getting more or less overlap, or might be getting more or less spill depending on the FTSE signals that are coming off of the 1,000 cells that are going through.
Now, obviously, this is totally unrealistic for just like logistic reasons, but if you were able to take each FTSE signal, and like you said, per cell, it can be slightly different. Do you think that is a function of like the inherent autofluorescence of the cell plus the FTSE? Or do you think there is just some spread in FTSE either because of like the detection or the molecule itself? Or I'm just kind of curious. Like if we could perfectly cell by cell do autofluorescence extraction, which is obviously impossible, do you think that would go away?
Yeah, I mean, I think there is some component of autofluorescence that gets muddled in with the spectral unmixing.
I agree with that.
But I think even if you controlled perfectly for autofluorescence, you would still have this problem to some degree.
Do you have a guess as to why you would think that?
I mean, I don't know. I would point you to the spectral unmixing episode of ChUG.
Perfect plug. We love to see it.
What was that, like 2020?
Yep. It's the second.
It was definitely so probably around this time 2020.
Yep.
With Dave Novo. He like goes into like, I don't know. I mean, he starts talking about Poisson versus Gaussian, blah blah blah, this and that. Shows some equations and whatnot, but you can follow it. Like as soon as you start hearing him explaining and walking you through, you're like, oh yeah, this makes sense. But for me to try and represent what he was saying, I will do a terrible job of it.
I won't put you on the spot like that. I'm curious, does anyone here think that compensation on top of unmixing is like totally verboten? Like you can't do that?
Well, let's take a more general approach to that question, because like our approach to teaching people about unmixing problems has been to throw them back to the bench and do better controls. And if you have a problem, it's because your controls are bad, or your unstained is not the same, or blah 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 blah. But we never came with an actual answer to, once you've done all that work and you're pretty sure your controls are not getting any better, what do you do then? And there's a group, I guess most people will silently kind of switch stuff around and kind of correct stuff manually on the unstained control without telling anybody, because they know that somewhere in the world Rui Gardner is there and watches over us, and if he knows that you did that, he will find you and he will kill you. Allegedly. I don't want him to sue me. Is it allegedly that you say whenever you don't want somebody to sue you, or is it presumably?
Allegedly.
Let's just do both to be safe.
Allegedly and presumably, Rui Gardner will murder you. And he's super sweet. I love the guy. He's super nice, but he's crazy.
Rui Gardner, ChUG podcast enemy #1. You heard it here first.
No. He's very nice. Like I said,
I think we'll invite him to the next one.
Yeah.
You know, just to defend his name.
Yeah.
David.
He doesn't have to. I said presumably and allegedly. He's probably
here's a weird
way to know if he murdered that many people. Like when he leaves the country, if we see the rate of goes down, then we know we're fine.
Well, psychometry.
I do not.
It's a tough sport.
but you see, like, but it's kind of like, it's kind of really harsh. Go back to your lab, or.
Well, certainly there is some amount of that. You know, just make better controls. But I will say, 100% of the experiments I've run on the Aurora, I've went in afterwards and added compensation to
100%.
some pair of channels.
Okay.
And I've gone through all the strategies that Debajit went through in his paper, the different beads, cells, buffers, all that kind of stuff. I've done all the iterations at least twice in depth to try and, get to this magical perfect set of reference controls that will give me good unmixing. And it never happens. Even still, like if it did happen, let's say that worked on that panel on that sample source. Okay. Now take that panel and run it on a tumor that you digested. Is that going to look perfect too? And if it doesn't, do you just leave it? Like it's obviously looks like this is overcompensated or undercompensated. Do you just leave it and say, oh, well, that's the answer it gave me, so that's what I need to go with? No, nobody's going to do that. Is it a great situation? No, because you make a lot of subjective decisions now with your flow data. And I feel comfortable the way that I do it. But if somebody else gives me their 30 color panel of data and shows me some bar charts, the difference between treated and untreated, I'm going to say, no. Let me look at your data. Let me look at your compensation. Let me recompensate it. Then we'll look at the bar chart and see if it's actually significantly different. But it's unrealistic for me to be looking over everybody's shoulder and saying, hey, I don't like the way you compensated that, or it wasn't this pair that really had the overlap. It was Fitzy in this other color that had the overlap that impacted this third color, and you just didn't see it. So it's a problem. I recognize that. I just don't think focusing on a certain type of bead or cells or anything else is the solution at this point. I think like a combination of, better detectors, less noise, better fluorophores, things like that, but a better unmixing algorithm. I mean, maybe there's ways to improve the actual algorithm itself. Somewhere there, maybe those can be optimized and that can get us closer to it. But yeah.
I don't know.
Go ahead.
Oh, thank you. I don't know off the top of my head, but in Dabash's paper, but also in your testing, Ryan, has this been on? Because I know that SciTech and Sony have slightly different unmixing algorithms. I know Sony's big thing is that they weight it, I think, based on where the most signal is, the primary detectors, I guess. Have you tested both ways? Do you see significant difference either way, or is it just kind of the same story?
All of my experience would be Aurora data.
I think also knowing why you're using the controls, why you're using this particular bead, or when you're to use the set, autofluorescence, or, you're trying to get the brightest bright and the dimmest dim, and, things like that. Why are you using the beads, or, making sure with the FMOs, things like that, to make sure you're aligning everything. So yeah, I think just understanding why you're using a particular bead, or when do you use the cells, and how it looks like Ryan said, if you're used to doing things in a certain way and you're getting the data, is that enough? No.
Well, and here's the thing, Rebecca, this is like what you just said, I think was important. Maybe it wasn't the exact point of what you're saying, but you said it anyways. I'm not going to take my one-off flow data that I ran on one sample without a bunch of biological controls built into it and say, this is the truth, right? I'm going to have FMOs. I'm going to have treated versus untreated. I'm going to have orthogonal genomics data to support my conclusions, right? So it's not like I need to nail this down so perfectly because this is the only data source that's going to support or not my hypothesis. So it's because of that, if I were to make a mistake in, say, changing compensation on unmixed data and maybe make things overcompensated or undercompensated, whichever way, so long as the differences that I'm seeing between treatment and no treatment are corroborated with the various controls, positive controls, corroborated with orthogonal data sets, et cetera, then I say, okay, this supports my hypothesis or does not.
I totally agree with that. Yeah. I mean, there was a discussion on Purdue recently about I think it was a user of a flow core. I took my samples to a core and they only compensated 3 of my 8 parameters or whatever. Is that okay? And I was like, well, I mean, yeah, for kind of like you said, Ryan, as if I don't not to put words in your mouth. I don't necessarily care if especially for sorting, if my data is perfectly compensated, as long as I have, if I can't quite tell where my PE GFP double positive is, as long as I have a PE only control, then I can be very confident about where that is. I do think you're right that we should not just, regardless of how perfect the algorithm is, we should not just say that is the truth. Yeah, I agree with that.
Well, I also think that knowing how these different fluorophores interact is very important as well for your, what are you going to be displaying together? What, that type of thing, to make sure that you're accounting for that as well,
Yeah.
Actually, to ask Ryan specifically, but also everybody, if you are to apply compensation on top of unmixing, are you looking specifically at single stained cells, or what do you use as kind of your true control for them?
Looking at unmixed data, you guys see a bunch of dots, but I see basically the matrix. So I'm just
Yes.
going.
It's your curse.
I mean, no, but yeah, I mean, I would say it's hard to explain because I'm sure people do it like this, but it's not. I would not recommend people to do this. So I basically just pull up n by n plots of fully stained samples and start changing the x-axis versus every other channel, and eyeball it and say, that looks like it should go up a little bit. That looks like it should come down a little bit. When I do put single stain controls and whatnot into that, if I do have either a fluorescence minus many, where I get rid of a lot of things at once, I'll use those as well to confirm that. But yeah, I mean, it's almost 100% eyeballing things.
That's very brave of you.
It's like the definition of cowboy compensation.
Right.
Yeehaw.
Yeehaw.
I have to ask as a follow-up then, will you increase spillover or compensation by eye, or do you only decrease? Do you only look for overcompensation, or do you truly just, this is going to look the way I wanted to look? Okay, all right. And that's an unfair characterization, what I said, but okay. You're a brave man.
Again,
Well,
if you have the
so
set of controls.
Yeah, let me also preface what I just said by stating this is a panel that I designed and developed and tested ad nauseum on multiple cell types, to the point where I know pretty much any pair of colors what the profile looks like on lots of different tissue types, sample types. And so when I now run it and something looks a little odd, I can make the judgment call to attribute it to a unmixing error as opposed to some biological difference. It's a judgment call.
Yeah.
But again, if I have biological controls present, that might make the judgment call a little bit more valid.
It's not a teachable skill.
It's not a teachable skill.
Yeah.
No, I've tried.
Well, I have to wonder then, you're talking about looking at someone's data and not taking it for granted. And I want to look at your compensation and see, how would you address someone looking at your compensation? How do you justify it?
I would love it.
You would? Yeah. Okay.
Yeah. I mean, I might need you to sign an NDA, but yeah, we can make that happen.
All right. Next week on ChUG podcast.
I've been sitting on my second part of the compensation tutorial I have on our channel, because that's the one thing, the one answer I don't have for my users. I never liked the go back to do more better controls, and so I guess the answer at this point still is, it's going to look bad. You can correct. When you correct, make sure you know what you're doing, and if you don't, then
I mean, someone push back if you think this is wrong, but I think if unmixing algorithms were perfect, we wouldn't need controls at all, right? because they could just preload, this is the signature of this fluorophore. And, you do QC every day and you can normalize it based off of that.
Right.
That is not the case, right? So clearly the algorithm is not perfect. But I don't know. There are people who will try to use controls that are 6 months old, and I don't let them.
I mean, the unmixing algorithm is based on building a library of signatures. So these are your controls, and then you try to the equation is just figuring out how do you use your library to get the signatures that you have in your sample. So you do need the control still.
No, but why couldn't they just like run every fluorophore when it first comes off the factory line? Sorry. And that's just good forever. Clearly that's not the case. So what's the variable we're missing here?
Yeah.
Lots of lot consistency as well with the reagents.
Sure.
There can be that variability, and then cells react differently all the time. So they might do something weird I don't know.
Yeah. Can I throw one more caveat into this? Lest I come off looking like a monster here. The amount of, I do have a limit as to how much compensation I would apply. Okay. It's not like I'm doing 84% compensation between two colors.
Where's the line? I do want to know.
So I think under 10 is at least legitimate. I try and stay much lower than that. When I'm getting closer to 10, or certainly if something is above 10, I'm just like, okay, that was a bad reference. Let me remake the reference, re-mix the data, see if that fixes the problem.
Right.
Many times that'll fix the problem because, like we just said, maybe I used an older reference that was from a different lot of E size 7 or something like that. So yeah, I would caution people from doing like lots of compensation, right? So if you end up having, what also kind of gives me a little bit more encouragement in doing this is like if I have a color that just seems to be problematic with many other colors. And I know that, okay, that one just didn't unmix properly because it's hitting all these other channels, all these other fluorophores. And so I have to make a little bit of adjustment across, 5 or 6 channels. But if I'm all over the place in the matrix, fixing this here, fixing this there, fixing that there, where it's like a lot of colors are now implicated and I'm doing lots of compensation, then I'm more critical of the references that I use for unmixing. So there's a lot of nuance to that, but even still, there's always something that I find like I should fix.
But so you put a number there, 10%. So 10% is actually pretty low, and it's actually, if you look at the budget's paper, it's kind of like the yellow guys, like the ones that they And he had a bunch of red stuff all over the place. So generally speaking, we'd still recommend if you have a pretty big panel that you're just getting started, look at as many controls as you possibly can. And
so my first go-to is slingshot beads. I run everything on slingshot beads.
Yeah.
Currently, I'm using the HyperComp multi-peak beads. Which gives you a better chance of not having something sitting in that 10 to the 6 plus range as your reference control, which I try and avoid that. If I don't get good unmixing with the slingshot beads, then I go to cells.
Right.
That's basically, I've given up on other beads just because I don't want to have stocks of 5 different comp beads laying around. So we've just, fully moved over. All of our reference controls are made with the slingshot beads. And then if those fail, or there's some line of their product that doesn't find rabbit. So for rabbit antibodies, I got to use cells, or things that don't unmix very well consistently. Maybe I'll use cells, but yeah. And I think using that has been more consistent than the previous beads that we were using, which are probably the UltraComp Plus or whatever
Right.
beads that people always use.
All right. I think we fixed this. And for the record, I want to say I don't really believe that Ree Gardner murders people who apply competition to.
You allegedly don't believe
Allegedly,
that.
I don't believe that.
So much backpedaling, so much backpedaling.
Rebecca, you got a new job, and we want to use that as a segue to discuss career in flow cytometry.
Sure.
It's like I
I've
think we
had a
discussed
lot of different careers in flow cytometry
Yeah.
myself. Yes.
because previous podcast we discussed why you would get inside a core facility, and now the question is, once you're inside a core, what's your
How do you get
track?
out?
In my mind, it's like either you stick to your job, which I'm doing, which is what I do, or you kind of move to like somewhere else in industry and stuff. And there, I don't know what else is in the world.
Sure. Well, I mean, a lot of the things that most people see are in the core, the core manager, technical directors, that type of thing. And then when you go onto the, into the dark side, you're going to have those same types of things within a company as well. There might be a core that somebody's running and all of that, but a lot of times people are making instruments. So you're going to have a product manager that would be in charge of the whole particular flow cytometer and getting voice of customer and getting information about cell types and running things and partnering with people, right? And then communicating with marketing and all those types of things. And then in that team, you might have test engineers who their sole job is to try to break the instrument, break the software, see what they can do to find bugs and things like that before they release that instrument out to the world. You also have, people within that are doing the R&D work within the company, right? To figure out what are these protocols, what are these things that we're going to need to release with the instrument, that, testing these solutions, make sure these things work properly. You also have, project managers that that are in charge of, maybe they're in charge of all the different platforms for flow to keep the project moving, make sure everyone's on task, they're doing all of their things that they need to be doing. And then you also have, I know, panel design professionals now in these companies. So if you're very good at panel design and stuff like that, I know there's people who sit in their house, or, it's a lot of remote stuff, or it could be at the company, but basically they're going to be talking to the end user about all the aspects of their experiment to figure out what they're trying to put together. And they will design a panel that is, obviously it's not foolproof. You got to test it out, but it's going to be a jump off point.
Mm-hmm.
So many people that might not know that companies can help you to that extent. I never knew the extent that companies could have helped me until I came to this side. But there's that. And then also, you have your reagent specialists as well. So people who just know everything about the reagents and putting stuff together for you, dye chemistry experts, things like that. So there's many other jobs that go along, if you're on the software programming side of things, there's always new things that need to be written, or your FASs are always good, the field application scientists, who are usually, kind of your core people that end up doing that on a bigger scale, right? They're going around to all different areas. So from my perspective, you just see a lot of different cell types. You see a lot of different things when you get into, working in the field, and then being in industry, kind of doing, you could do the same types of things that you do at a academic core, but in a different manner. I think Ryan can attest to that, right? At AbbVie. So Yeah, there's many layers of jobs within the Flow community that's outside of a core and outside of just like the technical salespeople you see or the field specialists or things like that. And of course, there's also engineers. So if you're someone who likes to tinker, then there's always that engineer part as well. So lots to do in Flow. So I don't think our jobs are going anywhere, guys.
No,
Circle back around.
that's the part we haven't. That's not recorded, but we were discussing before we started recording how
Yeah.
I'm getting sacked.
Our anxieties.
Yeah, neurotic part of my brain that's pretty sure I'm gonna get that.
Yeah, I think that there's a lot of guidance and leadership that needs to happen to make people feel comfortable when they're, because a lot of times look how much goes into a particular mouse they might be using, or, they've cultured these cells and they've done this experiment. Now they need these results. So I don't think that just, oh, okay, I have this instrument, I'm comfortable to just jump on it. I don't think there's a ton of people that feel they're going to get great data without any guidance on the first, few rounds of things. So
Yeah, just saying that to be nice.
I think there is an element of like, if someone publishes a figure that's imaging and they just completely make up a conclusion, not based at all on the data you see there, you can pretty easily pick that out. Like, oh, there's no DAPI signal there. That's not a nucleus. What are you talking about? Or, just a simple thing like that. But I think with Flow, there can be like this. I mean, we've been talking about unmixing and compensation. You can have, I've unfortunately seen it in person. You can have people who have this very mature, quote unquote, experiment that they think they have a really solid conclusion on. And it's like, all your cells are positive for every marker. Like, clearly this is not what you thought it was. And like, they could easily present a figure that shows the lie, right? So I think there will always be a place for people behind the scenes who can actually make the data real, but maybe that's also just a sad thing about the reality of Flow, that it can be kind of
also running into people who are just, they teach you a lot, they teach you so much that you never knew. So to circle back around as well to meetings and things, I think that's the benefit of going to meetings and being in the community and understanding and talking to people and figuring out, oh, you're doing the same thing. How are you doing that? What are you doing for this? How do you control for that? So that's another benefit of the meetings, I think, and staying fresh in the community.
Any specific skill set that you'd recommend people working cores right now that are looking for a job in industry that they should think about developing?
Time management. I know, like, legitimately, I think that's the biggest skill that I need to work on it more. I don't think I'll ever be done with that, but I think that's a huge skill that like everyone in science needs to have. That is kind of a soft skill that's overlooked, but you have to be able to fit all your experiments in a day, or you might as well not do research.
Yeah, I think like a technical skill, bioinformatics in general. Like you'd be surprised how many people don't understand statistics in a meaningful way that can be applied to the work that we do. Like I many times feel like I have to go back to, high school stats and say, okay, here is what mean is, here is what the standard deviation is, etc. So it's not like you got to be, writing code and doing all this crazy stuff. I mean, that's what ChatGPT is for. All you got to do is understand the statistics and know that when ChatGPT writes you a code and you get results, how do you interpret that?
Yeah.
But there's such a demand for people with that kind of mindset and those types of skills that can be applied to every position in industry. Like just understanding stats in general and using them to tell the story that you're trying to tell. I took a so I do think like programming is nice. I took a Python class with you know that BioTrack company, Mark Nardone. He sometimes pops up on the Purdue list. They do a bunch of like flow courses and
Oh,
genomics
yes.
courses and stuff like
Yes.
that. So one of them that he had was and I did it because it was virtual, so I didn't have to travel to go there, but did like a intro to Python um course with them, and it was awesome. I mean, I could do like very basic stuff, but it speeds up. Talk about time management, Bert. I mean, how much how much time do we waste just like staring at spreadsheets, looking at data? It's like I need to get from like my gating or my clustering to results. And are they significant? And start interpreting what that means as opposed to running through, 50 plots in Prism, being what things might look interesting. Right. So you can kind of cut through a lot of that nonsense and just, using some basic code, um, surface the important stuff that's going to be relevant to the biology you're investigating, and like make some conclusions as opposed to just staring at dot plots all the time.
Sounds good.
I can't say enough about networking with people because that gets you a far way. So if you're trying to break into some other area or some industry or something like that, chatting with people who work at that place or, doing that kind of thing. Yeah, know people, talk to them, don't be afraid of it. And yeah, you could do whatever you want, I think. If you have the background that you already have and from the core, you could do
I
it.
hate how right you are.
Yeah.
Well,
That's true.
Even though internally, like within your institution,
Mm.
it's very important as well. Not
Mhm.
just to make those connections and maybe they pay off in the future as that person moves on to bigger and better things, but like learning skills from other people. I mean, I don't know, David, we used to talk about like doing like cross training type stuff in different core facilities and learning different techniques and whatnot, but I had the opportunity to work more closely with our genomics core and learned how to do all of the steps of the 10x single cell RNA-seq process, like
Right.
from cells through sequencing, and looking at data in Cell Ranger. Like now, I do that pretty regularly, which has just increased, my capital, in terms of being a valued asset to the company. And so it's like, and it didn't like, so I mean, the protocol is basically just following a recipe like anything else. It's just a billion pipette steps. So it's not difficult to do. It's just you need somebody to show you.
Yeah.
You need somebody to walk you through it. But once you do that, like, oh, now I have a new skill set. I have a potentially a new service, maybe even a new revenue source that I could add to my standard flow stuff. And it's going to be a benefit to the investigators. It's going to be a benefit to the sequencing core because now they can just throw those libraries on the sequencer and make money that way. But yeah, I mean, I think like there's a lot of untapped potential, especially in an academic institution, of doing that
Mhm.
cross technology collaboration and even training if you can get to it. But I know it's usually something that sits on the back burner for a long time.
I would say also in an academic sense, the ability to adapt to different things that are happening, because I remember when Kevin Weller was down at Vanderbilt and, a lot of people started getting instruments in their own labs. Well, he then started having a service where, hey, you could pay us and we'll come and service your instruments, right? Like, or keep them up, make sure we run the QC, do that kind of thing, right? So instead of, just staying in this little box or whatever, figure out how to get another revenue stream for the core, or what other types of things can we offer, right? Like you're saying, Ryan. So yeah, just keeping on top of what's happening around you and talking to other people, it just opens up your mind so much.
like curiosity, right? That's such a huge, I mean, for anyone in science, you just have to have that desire to know new things. That can be like a new avenue of research, or to something we were talking about earlier, can be like, hey, maybe spatial biology could be a thing in the flow core. Just these open-mindedness, I guess.
Yeah.
Gotta have it.
All right, guys, we're gonna stop here. It's been a long show. Thanks so much for coming. Thanks for your time. And thanks for viewers for following us through this discussion. If you have any opinions about, how to clean the machines, if you've seen Ree Garner, leave that in the comments. Let us know where he is at all times.
Oh, no.
And we'll talk later.
Bye.
Bye.